In part 2 of section 20, we're going to be looking at the fourth and final property of logarithms before we get into section 21 on solving exponential and logarithmic equations. Example 20.3 is going to take us through a guided practice, guided example on the expression y equals log base b of x. So I'm going to copy down the expression y equals log base b of x. And I'm going to use the equivalency definition for the log and exponent to rewrite this statement in exponential form. That would be base b, exponent is y, all equal to the argument. So this is the exact same equation, just written in a different form. Now I want to be able to take the logarithm of both sides of this particular expression. So I make an analogy here with what you might do in another solving situation. For example, if I say 1/2 x is equal to 7, then a lot of you are familiar with the idea of multiplying both sides of your equation by the same value. And that's what we say keeps the equation balanced. Now it just so happens that since I chose 2 times 1/2 ends up being equivalent to 1. And then 1 times x is just x. And then on the right hand side, 7 times 2 is 14, and we get x is equal to 14. So we have this notion that as long as we do the same thing to the left and to the right, our equation stays balanced. So I want to apply that same concept here with a logarithm. So I'm going to use the left-hand side and the right-hand side as an argument for a logarithm. So we're going to say log base a, and then for the argument I'm going to put b to the y. And that's what the left-hand side is going to look like. But if I do that for the left-hand side, I must also do that for the right-hand side. So I'm going to write log base a, and I'm going to use x for that argument. So once I've done this, I now have a log statement on the left and a log statement on the right, and my log statement on the left has an exponent of y attached to this argument, so I can bring the y down in front as a coefficient, and I can call this y times log base a of b is equal to log base a of x. In which case I can then divide both sides. That's another one of those solving techniques. As long as you divide both sides by the same thing, you're keeping your equation nice and balanced. So I'm going to divide by log base a of b, in which case it reduces to 1 on the left-hand side, and that leaves me with just y. And on the right-hand side, I now have the statement log base a of x over log base a of b. And this is what y is equal to. And that's the same y that we had at the very beginning for log base b of x. So if y is equal to log base a of x over log base a of b, and we originally said that y was equal to log base b of x, it is very reasonable for us to make the connection that these two statements must be equivalent to each other. This is known as the change of base formula. So we just went through and proved the change of base formula. On the next slide, I have a theorem that describes that for us, Theorem 20.2. It says let a and b be logarithmic bases, and x has to be a real number, and it also has to be greater than 0. This is for domain purposes. That's the domain of a logarithm. Then, if you have the statement log base b of x, just like we started with on the example, then you are permitted to write that as log base a of x divided by log base a of b. As long as a is chosen to be a logarithmic base, we shouldn't have any problems. Now, when I say logarithmic base, those are the same conditions that we've had on our base since we started with exponentials. That is, has to be positive, and it's also not allowed to be 1. So as long as your base is there within those parameters, then you can pick whatever you want. But I really don't want you to have this choice of A to be too large. Your calculator has an LOG button, and it also has an LN button. So if you let A be equal to 10, then you end up with this version of the statement, which is using common logs, log x over log b. If you let A be the natural base with E, then you end up with this version of the change of base formula. So you really can change the base to whatever you want, but you're going to want to change it to something that's convenient for working with your calculator, and that would be a common log or a natural log. More on this to come with the upcoming example and also in section 21.